So, good morning everyone. So, this is the video lecture on data structures. So, we are currently discussing with module 4, that is trees. So, trees, we have gone with types of trees. So, types of trees, we have binary tree, fully binary tree, strict binary tree, almost complete binary tree. Next, we have seen some of the properties. So after that, in yesterday class, we have gone with traversals. So traversal means travel in the tree. You are traveling from root node to leaf node. So traversal is nothing but path from root node to leaf node in which you travel. So that one we call it as a traversal. So in that we have seen three types of traversals. So first one is preorder. So preorder means root comes before child. So keep in your mind, pre means before. So root comes before left and right child. Next comes in order. In order means root comes in between left and right child. Similarly, post order, root comes after. Post means after. So root comes after left and right child. So that is the traversal technique we have seen. So in today's class, we are discussing with a new topic, very important topic. So each and every question you will be having. So this one question from this. So what is a binary search tree? So we have seen binary tree. What is binary tree? Binary tree is a tree which consists of 0 or 2 children. So binary tree is consisting of 0 children or 2 children. So in that now we shall see what is binary search tree. So search tree is a binary tree in which, so you have two nodes. One is the left node, the other one is right node. So left nodes contains lesser value than parent. So that means left node contains less value than root, and right child contains greater value than root node. So parents is nothing but root node. So left node contains less value than root, and right node contains greater value than parent. Okay, that is root node. All the subtrees of binary search tree are also binary search trees only. So which are the, this is the example we have taken. First you see, first root node. So root on left you should have the value lesser than root. So root node is containing value 20. So on left it should be less than 20. So see here we have given it as 10. And come for right child should be greater than the parent. So who is the parent? 20 is the parent, so right is containing 30. So this, if this is the case, then we call it as binary search tree. So for 20 on left you have 10, which is lesser, on right you have 30, which is greater. So now you come for the 10. So coming for 10, it's again containing two children. So left you have 5, that is lesser than 10, and right you have 15, that is greater than 10. Understanding? So that means in the binary search tree, all the left nodes should contain value less than parent, and right node contain value greater than parent. So similarly, you come for this 30. So 30 consists of left as well as right. So now you can say 25 is the value that is lesser than 30, and 50 is greater than 30. So again coming for this 25, you see there is no left, but you are having right. So right means it should be greater than parent. What is the parent? 25. So right child should be have the value greater than 25. So that's why on right we have given it as 28. Okay. So in general, BST means binary search tree does not contain duplicate values. So it will, if one node is containing 10, here you can't have any of the values as 10. Okay, so no duplicate values will exist here. So now you come for the traversal. So this is the tree we have taken. So for this tree, we have to check what is the in-order, pre-order and post-order. So come for this particular concept, in-order is very easy. So write all the elements in sorted manner. So in-order traversal produces the items in sorted manner. So take all the elements and sort it. Take all the elements and sort it. So first is 5, next goes 10, next goes 15, next 20, next here 25, 28, 30, 50. So if you are sorting all the elements from a binary search tree, then it is called as a in-order traversal. So how the in-order will work? So in-order in between. So root will come in between left and right. So on left you have 5, on right you have 10. So that's why you get 10 in middle. Understood? So next, you come for the pre-order traversal. Pre means root comes first, then comes left and right. Okay, so see here, root comes first. So root is 20. So 20 is given here. Next, you come for root, left and right. So after root, you come for the left. So this is again root because it contains two children. So that's why we take first will 20. Next you come for the left part. It is also a root node because it contains 5 and 15. So that's why we give it here 10. So that is root is 10. Next you will go for 5. Left is 5. Right is 15. So 20, 10, 5, 15. So here you can see up to 15. Okay. So after that, now you come for the right. So coming for the right part, first you have root. So 20 is already there, which is the next root. 30 is the next root. Okay, because when you tell it is a root, when it has two childrens. So kindly understand here. So it is a right node. So, but it is a root node also because it consists of two childrens. So that's why we consider this one as root. Then you will come here 25. So 25 is also containing the node. So this one is root. So this one will comes again root. So after 30 you will get 25. Left is not there, right is 28. So you have given right 28 and finally you print the remaining value 50. So now you come for the post order. Post means root comes next. First will after left and right. So root. Okay. So again go down until you get the leftmost part. So 20 is the root. Again go down. 10 is also a root. Again go down. First you will get left is 5. Right is 15. Next you go for 10. So 5, 15, 10. So this part is finished. This will comes last. So topmost root node, you will get it at the last method. So again you come here, this is root. So it comes next, finally, next, this is again root because it contains node. So now you see, here you will get 25. Next you will print root. Root is 25. Next you will print 50, next 30, next 20. So this is the pre or post order traversal. Understood? So that is the binary search tree what we can take. So now you come for this particular example, insertion in BST. Okay, so that means you are inserting into the BST. Okay, so nodes are inserted or added as leaf node following the rules of the binary search. So following the rules of the binary search. So how you insert? Insert 45, 23, 12, 56. These are the numbers we have given. So now you have to give, sort the insert all the elements in the binary tree. So first you start from 45. So next, what is the next value you have? 23. So 23 is lesser than 23 is lesser than 45. So it comes left. What is the next element? It is 12. So 12 means it is lesser than 23. So it comes left. Next you will get 56. So 56 you have to check. 56 is greater than 12. It is greater than 23. It is greater than 45. So that's why we are placing it on to right, because left part will always contain what? Lesser number than root, and right part will always contain what? It contains greater than root. So that's why we have given 56. Okay, so 56. After that, what is the next value? It is 43. So now you see here 43. So you see after 45, now it has left and right. So come for the next one, 23. 23 on left, already 12 is there. Now as the value is greater than, 23, so here we place 43 on right. So what is the next element we have? 29. So 29 means you can take it on right of 15 or you can go with left of 43. So keep in your mind 43 is there, you have placed 29 to left of 43 because 29 is lesser than 43. So 29 comes here, next comes 87. So keep in your mind, so 87 means, so you can place it right of 43, also you can place right of 56 also. So that's why we have placed right of 56, we have placed 87. Next comes 65. So 65 is, you can take it left of 87. So you can also write right of 43 also, because right of 43 you can place 65 or you can left of 87 you can place 63. So that's why we have given it as 65. Next comes 15. So 15 is the value. So where you can place the 15? So you see after 12 you can place right of 15. So right of 12 you have placed 15. Next comes 40. So 40 can be placed right of 29, and similarly 30 can be placed right of left of 40. So this is how you insert the values in the binary search tree. So while inserting you can take any trees, but the thing is you have to check the left child should be lesser than root node and right child should be greater than root node. So that is the only concept you have to keep in your mind in order to make this insertion possible. So after the insertion, now you can take the Inorder and all the traversals. So Inorder, I have already told you, Inorder means place all the elements in ascending order. So here I have told you, Inorder traversal produces items in sorted manner. So that's why here you see it is starting from where? 12, 12, 15, next 23, 29 up to 87. So whereas you come for the pre-order traversal, pre means first you will get what? And anybody can answer what is the pre-order traversal? How will be the pre-order? How will be the pre-order traversal? Left pre, sorry, it is pre. Pre means before. So which comes before? Root comes before left and right. Okay, good. So it is root comes first, next left, next right. So in order, traversal. Yes, tell me. In order. So in order, so you will be getting it as left, right and right. Okay, good. So in order means it is placed in between left and right. So which is placed? Root is placed in between left and right. Okay. So that we have to see here. In order means you place each and everything in sorted order. Pre-order. So I will tell you the traversal again. So you can see here. Pre-order means root comes before left and right. So first root is, so root is 45. Next you see left you have 23. So 23 is also a root. So you print the root. Next you come for 12. So 12 is also a root. So when you tell it as root, when it contains two children. So 12 is also considered root because it has right child 15. So that's why we have taken 12 root, left you don't have anything, on right is 15. So now you go back. So on right you come for this part. So this is again the root. So 43 will come, next 29, next 40, next 30. So finally you go for here 56, 87, 65. So you start from root left and right. So come for the post order. So post order means first comes left, next comes, so post order left, right and root. So that will be the series. So for this is the root, left child. This is again root. So left you don't have anything, right child. So right child. Again go back. So here you have left is there, 12 is there. Now 23 is go for the right part. So go up to depth. So 30, 40, 29, 43, 23. Now again 65, 87, 56, 45. So just you keep on moving from down to up. So that comes post order traversal. So this is up to how you insert the values into the binary search tree. Now you come for the delete. So what is the cases in delete? When we delete a node, three possibilities arise. If a node to be deleted is leaf, simply remove the tree. Simply remove from the tree. So if you are deleting the leaf node, okay, so what should be done? Simply remove from the tree. See the example, the first box here. So leaf node we have deleting 20. So where is this 20? So 20 is fully down. So when you delete the 20, simply remove from the tree. So this is the case. So 20 is been deleted. Now you come for the second case. So delete node to be deleted as only one child. So when you have the node to be deleted as only one child, what you will do? Copy the child to the node and delete the child. So copy the child to the node and delete the child. So here you see, so you are having 50, 30, 70, 40, 60, 80. So 70 contains two children, 30 contains one children. Suppose if you are deleting this one, so what? Copy the child to the node. So what is the child? If you are deleting 30, so 30 is containing one child. So which one it is? It is 40. So copy that child to 30's place. So if you are deleting 30, copy that child to this particular location. So here you see, when you delete 30, 40 will come and sit here. So see here, 40 is been. From here, it has deleted 30 and you can see 40 here. So now node to be deleted has two children. So if there is two children, so what is the two children? Who is having two children in this graph? So 70 is having two children and 50 is having two children. So what you should do, that you keep in your mind. So find, if you are deleting a node with the two children, what should be done? Find the in-order successor of the node, copy the contents of the in-order successor to the node and delete the in-order. So here you see, here we have 50, 40, take this entire graph as it is. 50, 40, 70, 60, 80. From this content is been placed here. Understood? So now you are deleting 50 because 50 is containing how many? 50 is containing 40 and 30. Now we are deleting. Okay, when you delete, what will happen? Now you have to see. So when you delete this one, who is the in order successor? So in order means first comes left, root, right. So in this place, so find the in order. 50 is, if you are deleting 50, find the in order successor of the node. So in order means you have to go with a child. This is the successor and he is the in order successor. 60 is the in order successor. So because you can tell in order means left, root, right. So who is the leftmost child? So leftmost child is 60. So 60 will come in place of 50. When you delete 50, what will be the case? So 60 will come in place of 50. So that will be the series. Okay. So important thing to note is in order successor is needed only when right child is not empty. So in order successor can be obtained from finding the minimum value in the right child. So finding the minimum value in the right child. So right child minimum value 70, 60, 80. So who is the minimum value? 60. So the E is called as a in order successor. Understood? So in order successor is needed only when right child is not empty. Right child is not empty. So this may be replaced with highest value of left subtree or least value of right subtree. So this is up to binary search trees. So insertion operation and deletion operation. So these are the three cases you have to see. If it is leaf, what should be done? If you have one child, what you will do? If you have one child, simply move. If you are deleting that particular node, move the child to that node. If you are not to be deleted as two children, so what you will do? So you are going to find the in order successor. So in order means you will get left, right. In order first you will get left. So move that one to here. So this is up to deletion in binary search tree. So you have to go through these important questions. So deletion in binary search trees, one for leaf node, one child and two child. Okay. So next you go with a important program binary search tree that we are going to create, insert and delete. So you are going to create, insert and traversal. Okay. So how you do? So that we shall see in this particular program. So here you have to create, insert and traversal. So first you start from here. First you will get a structure tree you have taken. So tree will consist of how many? Three parts. One is left child, the other one is right child, the other one is data. Data, struct tree star left, struct tree star right. So first you are inserting the data. So how you insert? So first dynamically allocate. Next you write p then data is equal to data. If it is only one node, what you will write? P then left is equal to null, p then right is equal to null. Okay. So if there is no new node, not of p means there is no tree. So if there is no tree, create one node and press make left as null and right as null. Else you come for the last part. If data less than p, then data. If you are inserting a new one to already existing, So at that time, you write if the data is less than node, where you will put? You will put p then left up. P then left is equal to insert of data comma p then left. Else if p data greater than p then data, p then right is equal to insert of data dot p then right. So now you come for the concept preorder, inorder, and postorder. So preorder traversal, tree then data, tree then left, tree then right. So in order also I have told you tree then left, tree then data, tree then right. And post order I can tell you tree then left, tree then right, and tree then data. So this is the traversals we have taken. So now you move for the main function. So inside the main function now we can take choice 1 for insert, 2 for traverse. So if choice is equal to 1, what you will do? You are going to enter the number to insert. So now you call insert function. Else if choice is equal to 2, you have to go with all the three cases. First case, in order of tree. Second case, pre-order of tree. Third case, post order of tree. So else if choice is equal to 3, break. So this is the program on binary search tree and how to create the tree, insert a node and perform the traversal. So these are the kindly references what we have gone through. So you can go through this thing. So have you understood the concept? Have you understood? Okay, so I hope you have got understood this particular concept. So that is we have discussed about binary search tree, insertion, deletion, and traversal. So this is up to this particular class. So remaining thing we shall see in the next coming classes. So if you have any doubts, you can ask me. Okay, so all these video lectures will be uploaded in my channel YouTube ID 1DPMK. So that is already so many videos are being uploaded. Kindly subscribe for the channel and share so that it will reach a number of users and they may understand the concept well. Okay, so see you with the next video. Thank you one and all.